The next speaker here we have is Ben Goertzel. He's the CEO of SingularityNET and is the chief scientist of robotics firm Hansen Robotics and financial prediction firm Idea Holdings, chairman of AI software company Novamente LLC and bioinformatics company BioMind LLC. His research work encompasses artificial general intelligence, natural language processing, cognitive science, data mining, machine learning, computational finance, bioinformatics, virtual worlds, and gaming, and other areas, as you guessed. We can, if you open the dictionary and find all the words that they're kind of like super duper geeky, you can add them there, and then that would explain what Ben does. So he has published a dozen of scientific books, 100+ technical papers, and numerous journalist articles. Please help me welcome Ben Goertzel.
Yeah, it's really a pleasure to be here in a room of so many people interested in the the intersection of AI and blockchain. Like Tufi and many others, I've been pushing on these sorts of ideas for quite a long time, and now we're at a juncture in history where the world at large is waking up to the importance, value, and potential of these ideas. And I've really enjoyed the talks this morning from Tufi's invocation that Bitcoin itself is a kind of self-organizing AI, and we had talks on, or panelists discussing inductive, abductive reasoning, all different sorts of AI and how they connect with the decentralized ecosystem. I'm going to try to contribute to this emerging web of ideas by telling a little bit about my thinking on general intelligence and its emergence, the role of blockchain in allowing decentralized general intelligence to emerge, which is what we've been doing with SingularityNET, and then talk a bit about some of the broader ethical, social, and even singularitarian implications of all this. Let me begin with just something I've talked about a lot of times before, and I don't even need to go into it in so much depth now, because unlike in 2003 or 4 when I introduced the concept of AGI, now it's being thrown around even in the popular media. And I think there's more and more understanding that while the AIs we have all around the world today serving very narrow and specific functions, they're incredibly valuable, and they're pervading every industry and helping people in all aspects of life. Nevertheless, these narrow, very specialized AIs are in some respects a different thing from the general intelligence that humans have. I mean, human beings are able to deal with new situations that we weren't trained, prepared, or pre-programmed for. And as the next few years unfold, for AI to realize its true potential, we're going to need to create AIs that have the same sort of general intelligence, ability to transfer, learn, generalize, create, imagine that people have, and ultimately even more of these general capabilities than human beings have. We need AIs that can not only learn from labeled training data sets, but can learn from their own experience in the world, from the things they do and the things they perceive. And this experience-based learning is what fuels the ability to imagine and create. And fortunately, we have a lot of amazing tools that can be used to fuel this sort of development. I mean, deep neural nets are well known and are certainly part of it, but they're far from the only part. There's a lot of other amazing AI algorithms out there. We heard this morning from our friends in Minds AI who are looking at logic systems, inductive, abductive reasoning, which is great stuff, and we do some of that in my own work. There's evolutionary learning, genetic programming, there's stochastic local search inside SAT solvers. I mean, there's more amazing AI tools out there than people outside the field recognize. And these are all being pulled together in very interesting ways in modern work. So one thing we do in our OpenCog approach is connect together many different AI methods on the common knowledge representation, which it somewhat resembles what we called a blackboard architecture back in the 1970s and 80s, but our blackboard is now a self-organizing, weighted labeled hypergraph that uses the blockchain to distribute itself across many machines around the globe. But the key point is you're connecting multiple AI algorithms together in a common representation. We're using this in R&D projects to build toward general intelligence, and we're also using it to a bunch of practical things. We're working on genomics data aimed at fostering longevity medicine in partnership with a company called AI, and we're working with Hanson Robotics to use our AI tools to power the Sophia robot. So some of the same AI tools that link together genetics data in the AI application with the gene ontology and all the biomedical research on the planet, this same global AI network can be used to power some of these amazing robots being made at Hanson Robotics. And there's a lot of interesting things we're doing with these robots and their cloud-based AI minds. One application I want to highlight is we're using the Sophia robot as a meditation assistant. This is a video from a trial we did in Hong Kong.
Place your attention on your face.
So the robot was facing the person, looking them in the eyes and trying to guide them through meditations.
Really notice how it feels. Move your attention now to your whole head.
Seems to be a bit of a sound video.
How does it feel?
Feels good.
Maybe it's a dislocation of the space.
Feel its presence.
So this sort of robot is not the only path to general intelligence. I mean, the crux of general intelligence, as we're going to achieve it, is really a whole bunch of different AI algorithms, learning, reasoning, generalizing, and all different types of data collected in a global information fabric. On the other hand, if we want AIs that can interact emotionally and socially with people and understand human culture and human values, then humanoid robots like the amazing Hanson robots are a tremendous user interface to add to the mix of all the different interfaces to the global AI mind matrix. And I had some other videos of the robots here, which I won't show, but I wanted to highlight also, we're using neural networks to make Sophia's head movements more and more realistic by training neural nets on human head movements. So there's many different aspects here, different little ways to use AI to make robots more intelligent and infuse them with intelligence from a global AI network. And if our R&D is successful, then as the next decade progresses, these AI robots will progress more and more toward general intelligence. And the robot's beautiful to look at. It's an incredible engineering and artistic and character achievement. In the end, most of the intelligence in the robot is not sitting inside the robot. It's in the cloud, which the robot is connected to. And this ties in with what we're doing in SingularityNET and what a bunch of other blockchain-based AI projects are also doing.